a recap of 4.1, coming up with a polynomial function for this, right? We see we have 3 zeros and a point, right? And one of the zeros has a multiplicity of at least 2. Now, when you do a problem like this, I'm not going to like hide zeros from you. I'm giving you every zero that there is, and so we should really see that this is an x to the fourth type of problem. But you're definitely going to want to kind of list your multiplicities, your zeros, things like that. So I went through 1. I went through -1. I bounced through 0, 1, right? And I bounced at +1, and I went through at +2. So there's my function, and I'm thinking it's some kind of quartic, right? For x to the fourth. I want to list my zeros. I want to list their multiplicities, right? And so I have a -1, a 1, and a 2. And I think my multiplicities are 1, 2, and 1. So I'm taking a couple of assumptions, which are safe to take at this point, and I'm making sure that when I come up with my function and I graph it, I get something that looks very, very similar to it, right? So I know that I can write these zeros in as singletons first, right? But then I probably want to group things together if I have multiplicities, right? So a times x plus 1 times x minus 2 times x minus 1 quantity squared. And I can put those factors in any order, right? A times b times c is the same as b times a times c, right? It doesn't matter which order we put the factors in. But now I want to find the value of a. And what should I know about a right away? What's the mother here? What's the mother function?
The mother function is a negative x squared.
Not x squared.
Is it 4?
X to the fourth, yeah. So I'm going to get some a x to the fourth, right? And because I see that the graph is, I know the worst case scenario for an x to the fourth, right? 4 zeros, 3 turns. How many turns do I have, by the way, on my curve? How many turns do I have here on this curve? Remember, I'm in a helicopter looking down on the page, down onto the screen, and I'm driving, right? So I'll put my wheels here, and my car here, and I'm driving this way. So when I start, I'm turning to the right. How many turns do I have total? I got a right turn, I got a left turn, I got a right turn. So I'm really convinced, right, that it's an x to the fourth, because I've got multiplicities of zeros that add up to 4, and I have 3 right, 4 minus 1 n minus 1 turns. So I'm really convinced it's an x to the fourth. Everybody with me?
Israel.
Anybody else?
Yes.
Thank you, Rachel.
Yeah.
Thank you, Sarah. Thank you, Thuria. Thank you, Brian.
Yeah.
Thank you, Jarrett. Thank you, Benjamin. Cindy. Yvonne. Nice. Oh my God. So much better to be back at my desk. I can't wait to be back in the classroom. Anybody not looking forward to going back to school?
Me.
Why? Why?
Because it's just like, it's too much to like get up early and then go to school. I just like going on my computer.
Yeah. You don't. There's a lot more time available to you, right? Ryan, why don't you?
Exactly.
Yeah, Ryan, why not?
It's exhausting.
exhausting just to
Like Saturday,
get
I wake
places.
up at 6 and I have school all day at
Oh,
campus.
yeah, that sucks. So we're
Better to just stay at home.
I want to get out of here. My girlfriend and I are driving each other crazy. Shh, she might hear me. Okay. So I need to find the value of a. So what is the point I have? I have the point 0, 1, right? So you always need some non-zero, non-x-intercept point to be able to plug in order to find that value of a. So we know that f of 0 should be 1. So that means a times 0 plus 1 times 0 minus 2 times 0 minus 1 quantity squared should be equal to 1, right? And it looks like I get negative 2a is 1. So a is negative 1/2. And that makes sense that I would get a negative, right? Because of how the curve is reflected down. All the positive y's become negative y's. And here's my final f of x. And then I'd want to graph it and make sure, right? Graph it and make sure it's hitting those points. Hitting those zeros, bouncing the way it looks in the curve, right? Hitting that point 0, 1, etc. You can graph a point or multiple points on your TIs, but it takes a little bit of work and you have to open up the stat menu. But it could be worth it for you to research that. So I would just Google, so if I have a TI-83, I would say graphing a point and a function on a TI-83, right? Or graphing a vertical line. That's something that it's not that easy. Very easy to do in Desmos, but not easy to do on the calculator. So sometimes I'll graph vertical lines to show vertical asymptotes, kind of thing. Nice. So I think we're pretty good with 4.1. I can really imagine that this would be the problem. One problem I would ask from 4.1, and this seems like the one that would fit the best. Let's look at a problem from 4.2, okay? Now, if you look here at my table of contents here, you see that we're talking about how do you just creating polynomials in 4.1. 4.2 is that, right, finding all the zeros and factoring. We're still got a little bit more work on that. And then 4.3 is complex zeros. We're going to say if we get complex zeros, forget them. But if you're a math major or a computer science major, I would say read that section. For the rest of us, we only care about real numbers. We don't care about these numbers like square roots of negatives. We don't care about them, the rest of us. So let me pick a problem here from this section. I think I like 81 here. Let's do 81. So 81, so our process so far, we're trying to factor this with real zeros. Our process is look at the graph, find a zero, and start chipping away at the function using synthetic division. And the quotient that comes out is the book's calling a depressed equation. And so maybe we see two zeros. We start with the original function, get our new quotient, start with the new quotient, get an even newer quotient, and each of the times we're working on it, we're getting a factor, right? So let's make sure we got this one written down. Take a picture or whatever you want to do, jot it down quickly. Number 81 we're doing here. So I want to factor f of x equals x to the fourth plus 4x cubed plus 2x squared minus x plus 6. I want to factor that, right? It's just saying find the real zeros, but I want to find the real zeros and factor it. And again, once I get all my real zeros, if I have any complex, I just don't bother factoring there. So how many zeros should I expect to get at most? Wait, where are my crickets? Four, right? It's x to the fourth, right? X to the fourth. So now we're going to talk about today how would I find a possible zero without looking at the curve. We're going to talk about that today, but I'm not going to ask you that on the test. Okay. So this that new theoretical stuff I get to today, you don't have to worry about. So I want to go to Desmos. Is it okay if I use Desmos? Does anybody want me to use the TI?
Yeah, the TI.
Yeah.
You want to see it on the TI?
Yeah.
Sure. So it's just my screen is a little bit smaller, and it's a I call it a dinosaur, really. It's such a out of date piece of software. Desmos can do so much more. But let's take a look here. So I had what, x to the fourth, right? I forget already. Don't tell me. X to the fourth plus 4x cubed minus 7x squared. Oh, sorry, plus 2x squared minus x plus 6. And most of my graphs that I'm giving you should work on Zoom Standard. I think I typed something wrong. X.
Instead of plus 2 squared, you put minus 2 squared.
Thank you. Good catch. There we go. So most of the graphs, I mean, I'm trying really to give you graphs that are going to fit on this standard window, right? But you could always do Zoom Standard if it wasn't on that, Zoom, which is Zoom 6. And you could also do Zoom Fit, which I think is Zoom 0. Zoom Fit will get you a nice picture of the graph on the screen. So, but it looks like I'm hitting two zeros. It looks like I'm hitting a 0 of -3 and a 0 of -2. Do we agree?
Yes.
Nice.
Yes.
Yeah.
Sarah, you had asked for the 83. Were you able to follow me there and put that and do that on the 83 at home?
I was watching how you were doing it.
Yeah,
so
okay.
I did that.
Okay, nice.
I have a question. Can we check on like the table?
Yes,
with the
yes,
calculator to find the
absolutely,
two?
absolutely. Second table, you can see I can see a 0 at -3 and a 0 at -2. That's a nice way to double check and see if you're right. But remember, what I want you to do is show me on the paper that you're right. So how are you going to check and see if you got the correct 0? You're going to do synthetic division, right? And that's where we're going now. So we know we got a 0 of -3. Right? So because we're going to do our synthetic with what coefficients? Let's see, Elmer, what coefficients? What am I putting here in my synthetic division bar?
I'm not sure.
Okay, So I'm grabbing all my coefficients here, right? 1, 4, 2, negative 1, and 6. And I'm always bringing down that leading coefficient, and then I'm going to start to multiply and then divide, right? I'm multiplying here. Sorry, multiply and then add. So I get a negative 3, and then I'm going to add here, right? So I get a positive 1. And then rinse and repeat. So negative 3, negative 1, positive 3, positive 2, negative 6, and 0. And that's what I wanted, right? I wanted 0. I wanted to get the 0 there to show it's a 0. So now I know x minus 3 is a 0, right? And if x minus 3 is a 0, sorry, x equals minus 3 is a 0, then x plus 3 is a factor. You see how I can actually see that I moved that, took that negative 3 and moved it to the other side, right? Let's see, 4, 8, 12, 16, 21 students. Let me take attendance real quick. So once I get a factor, I can start chipping away at this f of x. F of x was x to the 4th plus 4x cubed plus 2x squared minus x plus 6. But now it's x plus 3 times that depressed equation. I think it's funny to talk about that as a depressed equation. I like reduced better. I hate going to the doctor because whenever I go, my tongue gets depressed. So I've got an x cubed plus x squared minus x plus 2. Get it? Tongue gets depressed. It's not funny? No, okay. Sorry. So now I want to continue, but remember I knew negative 3 was a 0. I also know negative 2 is a 0. So x equals negative 2 is a 0, but I'm going to use that new quotient, that purple quotient. So I'm going to check a negative 2 into that 1, 1, negative 1, and 2. Everybody with me?
Everybody.
Anybody else?
Yeah.
Nice. So I multiply. I get negative 2. Good. Good. Thank you, Matthew. Thank you, Thuria. Multiply, add, multiply, add, multiply, add. Good. I got what I wanted. I got that 0. So now, x plus 2 is a factor. If x equals minus 2 is a 0, that means x plus 2 is a factor. And remember my thought. My thought was saying, what number here would make that 0? Right? What number would make that piece 0? Is it a negative 2? So now f of x can be reduced even more, or depressed. Right? And now I have, what's my quotient now? It's x squared minus x plus 1. Is everybody seeing where that piece is coming from? Is everybody seeing where that piece is coming from?
Yes.
Yes. So at this point, now I only saw two roots, right? When I looked at the function, when I looked at the calculator, oh, please be still there. Yes, it is. When I looked at the calculator, I saw it hit only twice, and it looks like it's going through like a line. It doesn't look really curvy there, so it's like it would be a multiplicity of 3, right? Or a multiplicity of 5. It looks like a multiplicity of 1. So I'm suspect of, is there any more real roots? And so I will go, I'll say, well, let me double check that x squared minus x plus 1 does not equal 0 ever, right? And so I could either complete the square to solve this, or I can quadratic formula? Any preference?
Complete the square.
Complete the square, sure. So x squared minus x equals -1. When we have an equal sign, we complete the square a little bit differently. But I still see k. K is -1. Half of that is -1/2. And I square that, I get a positive 1/4. So I'm going to add 1/4 to both sides. On the left-hand side now, I have x plus half of k, quantity squared. And on the right-hand side, I have 3/4. -3/4, right? Yep. And so how do I solve this now? I'm going to take a square root. And you can see my issue right away is I've got the square root of a negative. Right? So x equals 1/2 plus or minus square root of -3 all over 2 is not real. And I don't care about the complex roots. I want to stick to real numbers. I don't want to deal with these complex numbers at all because I'm not going to have them in Calc 1. So I'm done, meaning I'm done. So f of x equals x plus 3 times x plus 2 times x squared minus x plus 1 is factored. With this little assumption of I'm only factoring to real roots and their multiplicities. No problem, Elise. Nice. So we did that. We're kind of all caught up to speed here on what we did on Monday and Wednesday, and and then some of the homework started talking about these rational roots, and so that's what we got to talk about. Talk about rational roots. Maybe do a couple more problems. Did anyone want to see me quadratic formula here? Did anyone want to see this with quadratic formula? Or
Yeah.
okay. So it's right. X equals -b plus or minus the square root of b squared minus 4ac all over 2. Sorry, you had to hear me sing. But x equals positive 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. And you can see I get the same answer right away. I get 1 plus or minus square root of -3 all over 2, which is what I got here. So that would be your choice. There will be a problem on test 2 that you have to complete the square, but it would be your choice to complete the square when you get a problem like this where you have to see if your roots are rational or irrational or complex once you get back down to a quadratic, right? Nice. So let's talk about our rational roots theorem. Now, this particular theorem is in your homework, but it will not be on your test. Okay? I think. Anyway, I'm going to try and make that happen. So, rational roots theorem. If f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus ... all the way down to a sub 1 x to the 1 plus a sub 0 has rational roots. Then they are in the form of plus or minus factors of a sub 0 over factors of a sub n. So we're going to take the leading coefficient and factor it as much as we can, integers of course, and the constant and factor it as much as we can. So what was the one we just had? We had f of x is, help me, x to the fourth plus all the way down to plus 6, right? The one we just did, yes? And so if I take the factors of 6, which are 1, 2, 3, and 6, and the factors of 1, which is just 1, I can see that I get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And obviously, I got the minus 2 and the minus 3 were the roots. So it's crazy. It's beautiful. It's hard to believe at first that if I'm going to have rational roots, they're going to come from the factors of the leading term divided into the factors of the constant. So I kind of want to work in reverse here. I want to work in reverse. I want to take some factors and put them together and see that, and I'll see that it's really that first term and the last term that's generating everything of importance. Okay, so looking at this, and I'm going to get my crickets ready. How can I think of why would the denominator never be factors of a sub 0? Let me get my crickets here for a second. I'll give you a second to think, but I'll ask it again. Why would that downstairs piece never come from? How could I remember that it would never be the constant? How can I remind myself that it should never ever be the constant down there? It should be the leading coefficient. Because you could easily imagine getting them switched, right? But why should I never think that the constant should be downstairs?
Because it won't be irrational anymore.
Jamal got it. I think you're trying. I think you're going there, Ryan. But Jamal said it in the chat. He said it could be undefined, right? Because the constant term could be 0, right? The constant term could be 0, but the leading coefficient can never be 0. Because if the leading coefficient is 0, it's no longer the leading coefficient. It's the next term will step up, right? So there's never a leading coefficient of 0. So the factors of the leading coefficient are safe to be downstairs. Nice. So let's work this out in reverse and see if we can notice that only our leading terms and our constant terms are really going to be deciding about zeros, right? Let's take something simple like 2x minus 1 times x plus 2 times x minus 2, and kind of see what happens here. What are my zeros here? What's my 0 here?
Half.
Yeah, 1/2. My 0 here is -2. My 0 here is 2, right? So let's see if those things come up when I start FOILing this thing out. So this is 2x minus 1 times x squared minus 4. And then I'm going to FOIL this out. I get 2x cubed minus 8x minus x squared plus 4. So 2x cubed minus x squared minus 8x plus 4. So you can really see, like when I'm just FOILing this last piece, that leading coefficient and that final coefficient are in play, right? They are telling me the zeros, and I'm multiplying with them, right? So now if I come back down to my constant term, that's a 1, 2, and 4, and then my leading term, that's a 1 and a 2, do I get to see my positive 1/2? Yes. I get to see my positive 1/2 here. There's my positive 1/2. Here's my negative 2 and my positive 2. So I can see all of those zeros in that little theorem there. So you may be asked, you may be asked to find a rational root that find a real looking at your graph, you can see where it goes through 0, but you might not recognize it, might not go through a tick mark. So then you're using this rational roots theorem to figure out where to start, right? So let's do another example here. Sorry. All right, see ya. I forget which one I did. I want to look at the one I did in the other class. Sorry. So it's 4.2, number 81, maybe. Nope. Don't tell me. All right, I can't find it. It's all right. I'll just pick one here. Why can't I find it? I'm sorry. I'm having my brain just stopped working all of a sudden for some reason. Well, let's do 76. Okay, just take a picture of 76 for me. No, 77, sorry. Robert, come on. 77, 3x cubed plus 4x squared minus 7x plus 2. 3x cubed plus 4x squared minus 7x plus 2. I'm going to write it down here again. And we want to factor f of x equals 3x cubed plus 4x squared minus 7x plus 2. So let's start our way, right? Our way is, let's graph it and take a look at what's happening, right? Let's graph it. So I'm going to do this one on Desmos just because it's just a little bit easier for me and easier for you to see. So y equals 3x cubed plus 4x squared minus 7x plus 2 minus 7x plus 2. And there it is. And so look at this. I'm not hitting integer points, right? I'm not hitting integer points. I see there's 3 zeros, right? But I'm not quite hitting integer points. So I don't know where to start. I mean, I could try and you know, put some values in, but it's not really clear to me. So what I'm going to do is look at my rational roots, right? So I'm looking for possible POS-RAT roots, right? So I'm doing factors of my constant, which are 1 and 2, over factors of my leading, are 1 and 3. So I've only got 4 choices. Well, it's 8 choices, really, right? I've got plus or minus 1, plus or minus 2. They're out, right? Those are no good for me because I see it on the graph already that those are no good. So what's up? Your keys? They're in the car. Wait a minute. Yes, what? The house keys? Can't see it. Say it. Oh yeah, the rest is in the car, and there's a Mazda key in the car. Yep. Sorry about that. And then I got what, plus or minus, 1/3 or 2/3, right? So I'm thinking it's 1/3 or 2/3, and I'm thinking it's positive, right? Right? Because just looking at where I am, you can see I'm figuring out that it's either 1/3 or 2/3. Now I can plot those 2 points on Desmos, or I could just do my synthetic division. So that's what I'm going to do. I'm going to just do my synthetic division right away here and see if 2/3 works. So 2/3 into 3, 4, -7, and 2. Is everybody with me? So I look at the graph, but I can't clearly see a place where it's hitting the x-axis. I see it's hitting the x-axis, but it's not real clear to me, right, exactly what that decimal is. So I figure out the possible rational roots and then narrow it down, right? So let's bring down our leading 3 and multiply. So what do I get when I multiply? I get a 2, right? And then add 6, and then multiply, I get a 4. And then add, I get a -3, and then multiply, I get a -2 and a 0. Okay, I found it. I found my real root of 2/3. So x equals 2/3 is a 0, and x minus 2/3 is a factor. Everybody with me?
Yes, sir.
So now I've got f of x now, right? Used to be 3x cubed plus 4x squared minus 7x plus 2. But now it's x minus 2/3. Oh, is that right? Yeah, 2/3. Why did I write 3/2? Times that depressed equation, which is 3x squared plus 6x minus 3. How are we doing here so far? Thank you, Theria. Manish, thank you. Yvonne, Wilder, Brian, Ryan, Sarah, thank you. I think Sarah's got a thumbs up there. Rachel, thank you. Nice. I want to keep going. I can see there's a factor of 3 there that comes out in that quotient I just got. So I got an x squared plus 2x minus 1 now there. And I want to try and factor that, but it doesn't factor, right? I can't find factors of -1 that add to 2. So I've got to go either to complete the square or to quadratic formula. Anybody have a choice? Anybody have a preference?
Square.
Complete the square. I like complete the square. So I'm trying to find when this part equals 0. And I know it does, because I look at my curve and I see it goes through 2 more zeros. So I'm going to get that plus minus 0 piece, right? So I leave my x squared and x term on one side. I move my constant to the other. I find k, it's 2. I find half of k, it's 1. I square it, I get 1. So I'm going to add 1 to both sides. And on the left, I get x plus half of k, quantity squared. And on the right, I get 2. And now I'm going to square root this. So I get x plus 1 equals plus or minus rad 2. And there are my other roots, -1 plus or minus rad 2. And those are real roots. Those are real roots. So I found all my real roots. I found 3 real roots, right? And I want to factor this now. I like to cheat a little bit. I'm going to call a -1 plus rad 2. And I'm going to call b -1 minus rad 2. And now I can factor f of x as 3 times x minus 2/3 times x minus a times x minus b. If I put those roots in, it gets pretty nasty looking. If I put those roots in, it gets pretty nasty looking. I can. I don't think the book will have you factor with these irrational roots. But I want to make sure you saw at least one. Pretty sure the book will not have you factor with the irrational roots. It'll always have rational roots to be factored completely, or complex roots, and then you don't keep factoring with it, right? Is that making sense? One more bit of theory that is not even in the homework, not going to be tested on, and that is René Descartes' rule of signs. So I know you probably have heard of René Descartes. He's I think, therefore I am. Cartesian plane, right? XY plane, that's is a mathematician, philosopher, whatever. But anyway, he had come up with this changing of signs. So let me use this function, and let me repeat what my roots were. I had a positive 2/3, right? I have a positive rad 2 minus 1. That's a positive, by the way. And I have a negative minus 1 minus rad 2, right? I have a negative 1 plus rad 2. That one's negative. So I have 2 positive roots, and I have 1 negative root. Okay? So here is René Descartes' rule of signs. I'm not testing you on this. I think if you're a computer scientist or a math major, you're fascinated by this particular thing, so maybe you look at it a little bit more. But let's look in the change. So this is, the rule of signs. So f of x, I'm going to use the one I just had, the function I just had, equal to 3x squared plus 3x cubed plus 4x squared minus 7x plus 2, has 2 sign changes. Right? Do you see it? Positive, positive, negative, that's a change. Back to positive, that's a change. So 2 sign changes. So René said, so f of x has 2 or 2 plus 2n positive roots. So 2 or 4 or 6 or 8, right? Of course, we know it's a cubic, so it can't have 4 roots, right? So we know in this case it has 2. In fact, it did have 2, right? What did it have? We got 2/3 as a positive root, and we got rad 2 minus 1, right? That's about 0.4. Is that right? Rad 2 is 1.4 something, I think. So we got our 2 positive roots. F of negative x is what? Negative 3x cubed plus 4x squared plus 7x plus 2 has one sign change. So f of x has 1 or 1 plus 2n negative roots.
It has 1 or 2 sign change.
Only one, because I start at negative and then move to positive only. So there's only one change in the sign. From negative to positive, and then it stayed positive, so it didn't change again. Yeah, Ryan?
Oh, so, like, you changed the first negative?
I plugged,
Yes.
remember I plugged in the negative x. So the 3x cubed turned to negative. The x squared stayed positive. The negative 7x switched, right? And the 2 didn't get affected at all. So only one sign change. Now I've already got 2 positive roots. So I know I'm only going to need one more root. So, but the theorem is saying 1 or 3 or 5 or 7, always 2 more than the number of original roots I get, or a multiple of 2 more. Pretty cool. Pretty damn cool. For sure, you can get the 4.2 homework done now. We are going to hopefully have a great weekend, and